Namaste. Welcome to the next video of Machine Learning Practice course. In this video, we'll introduce you to California Housing Dataset. We are going to use California Housing Dataset for demonstrating linear regression implementation in sklearn. While exploring this dataset, you will also understand the typical steps in dataset exploration that can be broadly applied to any other dataset. Let's begin. First, we'll load the dataset. So let's look at the steps. So we'll load the dataset. We'll see the description of the dataset. We'll examine the shapes of feature and label metrics. Then we'll look at the names of the feature. We'll examine the sample of training examples. We'll examine the features. We'll examine the target. We'll also examine details of features and labels. Then we'll see how the features and labels are distributed through histogram plots. And we'll look at feature and target statistics. And finally, we'll plot a pair plot between the features. So we are going to explore this dataset in these 11 different steps. So let's begin by loading the dataset. So California Housing Dataset can be fetched from sklearn with fetch _ California _ housing API. We can find this API in sklearn.datasets module. In order to analyze the dataset, let's load it as a data frame. In order to load this dataset as a data frame, we set as _ frame parameter to true in the fetch California Housing API. So when you execute this cell, we basically get California Housing data frame that contains the dataset that is fetched using this particular API. If you look at the type of this particular object, it is the bunch type, right? And we have seen that bunch is the type that is written by load and fetch commands. A bunch object is a dictionary-like object with the following attributes. It has got data, which is a pandas object, since as _ frame is equal to true, and each row corresponds to 8 feature values. Then there is a target which contains the average house value in unit of 100,000. Is also a pandas object since as _ frame is equal to true. Then we have feature names, which is an array of ordered feature names used in the dataset. We have DSCR that contains a description of the dataset and frame that contains data frame with data and target together. So here we just have the features in this particular data frame, which is data, and then in the target data frame we will only have labels. Rather, this is a series. In target series we have only labels, and the frame contains both the features and labels. So each of these attributes can be accessed as bunch object.key, and these are the keys. So in our case, we can access these features as follows. So if you want to access data, we use California _ housing.data, because California _ housing is a bunch object, and we access data through by basically calling California _ housing.data. That gives us access to the content of the data key or the data frame. Then we can, in the similar manner, access the target as California _ housing.target. We can get feature names, description, and frame in the similar manner. Now that we have loaded the dataset, let's explore it. Let's first look at the dataset description. We can print the dataset description, and you know how we can access the description. It is california_housing.dscr that prints out the description of this dataset. And you can see that in the description it is written that total number of instances is 20,640, number of attributes are 8, they are numeric, and predictive attribute, these are 8 predictive attributes, and then there is a target. And then there is a section on attribute information where the names of the attributes are listed along with a short description. So there is INC, which is median income in block group. Then there is house age, which is median house age in block group. Then there is average room, average bedrooms, which are average number of rooms per household and average number of bedrooms per household. Then there is a population, which is block group population, average occupancy of the household members, latitude and longitude of the block. There are no missing values as specified in the documentation. And this dataset was obtained from statlib repository, which is hosted at this particular URL. The target variable is expressed in hundreds of thousands of dollars. So if the value of the house is $200,000, the target variable will have value 2. If the value is $300,000, the target variable will contain value 3, and so on. There is a brief description about how this dataset was derived, and I have also given an explanation about household. So a household is a group of people residing within a home. So from this description, we will note down key statistics such as number of examples from the description. So there are 20,640 examples in the dataset. There are 8 numerical attributes per example. The target value, the target label is median house value, and there are no missing values in this dataset. Let's examine the shape of feature matrix. So we can obtain the shape by simply calling california_housing.data. This gives us data frame, and we call the shape on that data frame object. We get the shape as 2640, 8. So that means there are 20,640 samples or examples with 8 features. Let's look at the type of california_housing.data object, and you can see that it's a data frame. Now let's examine the shape of label. And when we get the shape of label with california_housing.target that contains the label series, we call the shape on the label series, and we see that there are 20,640 labels, one for each example, and the type of target is a series. So you should compare the shape of the target with the first dimension of shape of the data. So in this case it is 2640 in both the cases, and that should be the case. So this is a good sanity check to check whether the data and targets are loaded correctly. Let's look at the names of the features or attributes, and we can obtain them by calling california_housing.feature_names. We get an array that contains the feature names in order in which they appear in the data. So we have made INC, house age, average rooms, average bedrooms, population, average occupancy, latitude and longitude. So you should note down attributes and their description, and this is a key step in understanding the data. We should first know what each attribute corresponds to and how that attribute is calculated. So here we know that there are median income is median income in the block, house age is the median house age, average room is average number of rooms, and so on. Let's examine sample training data. So here what we'll do is, since you want to examine features and labels together, we'll use frame. So California_housing.frame contains labels as well as features. So we call the head function on this data frame to obtain first 5 examples. And here you can see all 8 features listed along with the 9 column, which is the median house value. And remember, this median house value is expressed in terms of hundreds of thousands of dollars. So here the price is 4.526. That means the price of the house will be $452,600. So this data set contains aggregated data about each district in California, and this aggregation is done via mean and median. So let's examine the features separately. So instead of examining the features and labels together, in this case we are just examining the features, and that's why we are using California_housing.data data frame. So now we have information about demography of each district. That is, we have income, population, and house occupancy. We also have locations of the district through latitude and longitude, and we have characteristics of houses in the district in terms of rooms, bedrooms, and age of the house. So since the information is aggregated at the district level, the feature corresponds to either averages or medians. We also examine the target by looking at the target series and calling head on it, so that we look at first 5 values in the target. And here the target contains median of house value for each district. And we can see that the target is a real number, and hence this data set can be used for linear regression problem. Let's examine details of features and labels by calling info on the frame. So when we call info, we get the following information. So there are 20,640 entries, and there are total 9 columns in which there are 8 features and 1 target column. So we can see that there are 20,640 non-nulls in each of the column, and the type of each of the column is float 64. So we observe that dataset contains 20,640 examples with 8 features. All features are numerical features encoded as floating point numbers, and there are no missing values in any feature. The non-nulls are equal to number of examples in the training set. Let us look at the distribution of these features and target by plotting their histograms. So we can plot the histogram based on the frame, based on the content of the frame data frame. So here we have plotted histograms for all 9 columns, which also include the target column, which is median house value. So we have to observe these histograms and write down our findings, which is one important step in the data exploration. So what do we see from this figure? We can see that this median INC has a long tail distribution. So the salary of people is more or less normally distributed. You can see a normal distribution type of things, but there is a long tail over here, and that denotes that some people are getting higher salaries. So house age is more or less a uniform distribution with certain spikes in houses. And the features like average room, average bedroom, population, average occupancy, the range is quite large, and it contains a small number of large values as there are unnoticeable bins in these regions in each of these features. And this may well indicate that there could be certain outlier values present in these features. Latitude and longitude carry geographical information, and their combination helps us decide the price of the house. So the target is also a long tail distribution. It spikes towards the end, and the reason for this spike is that the houses with price more than 5 are given value of 5, so they are essentially truncated at 500,000 US dollars. So that's why this particular peak. Let's look at the statistics of features and target, and we can obtain the statistics by calling describe on the data frame containing both features and target. So here we get the count, the mean of each of the feature, what is the standard deviation, and what are the values, what are the minimum and maximum values, and what are the values at different quartiles, 25%, 50%, and 75%. You can see that in average rooms, average bedrooms, average occupancy, and population, there is significant difference between 75th percentile and maximum, and that is what confirms our intuition about presence of outliers or extreme values in these features based on examination of their histograms. You can see that in each of the feature the difference is quite large between these two values. Finally, let us plot a pair plot, which is plot between the features, and what we have done is we have colored this particular pair plot with the target, which is median house value. So pair plot contains a lot of data. It has got all the features on the x-axis and all the features on the y-axis, and the way you have to read this is, so when you see this particular plot, there is mid INC on x-axis, median income on x-axis, and longitude on y-axis. So here you can see that and the colors here are by the value of the colors are based on the median house values. So there are 5 different colors that you will see, and they are listed over here. So you can see that median income is kind of indicative of the house price. In the same way, we can also see that the latitude longitude combined also gives us an indication of prices of the house. And you can see that there are certain features that have got extreme values, something like average occupancy or population, average bedroom, they have some extreme values. And we have seen this multiple times through histogram plots as well as through the statistics. So that's it from this exploration. We explored California housing dataset that would be useful for linear regression demonstration. We examined various features, various statistics of the dataset, looked at number of samples, number of labels. We examined distributions of features through histogram and pair plot. So hope you now have an idea about how to examine any given dataset. So there are certain steps that we took in examining this dataset which can be broadly applied to any other dataset. So in the next video, we'll use this dataset and build our first linear regression model with sklearn APIs. Till then, thank you and namaste.